This is Nathan Lyle, and this is my WEKA extra credit project. So to begin with, we will simply open our file. Now it's located in my WEKA folder in the data document, and I already converted it to the ARF file, much like the tutorial showed you how to in the simple CLI command line. So we're just going to go ahead and use that. And firstly, we are going to do string to word vector, which we can find in filters, unsupervised, near the bottom. So we'll just go ahead and do that. Now if I want to customize it a little bit, which I do, I'm going to go in here. I am going to, as you can see, I set my stops words handler to the rainbow option, and my tokenizer I set to the recommended n-gram tokenizer with a max of 3, min of 1. Words to keep I shrunk to 200, and as I would like to see the word count, I set that to true. So I'm going to go ahead and sit OK there. I'm going to apply. And there we are. Now if I scroll through here, I have the attributes, and if I go ahead here and select class for my visualization, I can now see all of these words and terms graphed against the positive or negative reviews. To demonstrate the usage of two different distances, I've come over here to clusters. I'm going to use a simple k-means clustering on my data set, which is located here in the clusters. When I click on it here, it gives me an option for distance functions. And for right now, I'm going to go ahead and keep the Manhattan distance. Max iterations I bumped up a little bit to 600. It was default set to 500. So we'll go ahead and apply that. And there we are, our clustered data set. We can see that it clustered it based on the Manhattan distance, and since we stored our cluster for visualization, we can now visualize it and take a look at the different XY attributes and how they relate to each other based on Manhattan distance. Now, if we wanted to try a different distance formula, we can select, for example, Euclidean distance, keeping all other variables the same. We'll run that, also storing the cluster for visualization. And now we can see, obviously, since we have a different distance formula, the output is different. Now, when we visualize that, much like as before, we can see graphed against different XY attributes their Euclidean distance. Now, if we want to play around with the visualizer tool that is built into WEKA, we can simply click on the visualizer tab, and I've upped the point size from the default of 1, which was very, very tiny, up to 4, and let's even do 5 for good measure. That way, when we are scrolling through, we can kind of quickly see if there's any distinctive correlations. Now, if we want to zoom in, maybe we want to know how the phrase movie is, if there's any correlation with bad and movie is. So we hover over that box and we can zoom in, and we can clearly see that indeed there is a correlation with the words bad and movie is. Now, if we then want to run this again against the entire data set, we'll now have our positive and negatives, where before we simply had positives based on one attribute. Again, we can see movie is and bad. And now when we click on it, we can get a bit more positive and negative information based on these data points, and we can definitely see that there are some outliers, but we're starting to get a correlation for sure. Moving on through, when we come to classifying, I ran a classification with Bayes.net, and it crunched some numbers and came out with some detailed information. And what we have here is the correctly classified instance and incorrectly classified instance, so the percentage of time that it would guess correctly given an unseen movie review and incorrectly. So better than average, but not great. Here we can see the number of times it was classified correctly for both positive and negative, and then incorrectly for positive and negative, since we have our matrix here. Going over the detailed information, we have our classes, so positive and negative. We have PRC area and ROC area. The PRC area, these are both accuracy measures. One is precision recall curve, and in fact these are both curve measurements where we measure the area under them and it generates an accuracy score less than 1. Anything from 0.7 to 0.8 is considered fair, all the way up to 1 being perfect and 0 having no accuracy. ROC is a more general classifier measure of accuracy, where PRC is typically preferred since it tries to take our class into account. F measure or F1 measure is also a accuracy measurement. Different than the curve measurements, it uses different statistical methods to formulate the numbers. Recall and precision. Recall is the percentage of the data set that was recalled for processing, and precision was essentially the correctness with which it placed each attribute. FP and TP rates. For FP, we have our false positive rate, or the rate at which it was not able to classify correctly a new instance, and this one is the rate that our model was correctly able to classify new information. The MCC is the Matthew correlation coefficient and is used in machine learning to test for the correlation between two separate classes. And this is the last accuracy measurement form.